common theme for our little section is looking at these equations and being able to solve these equations. And we're going to be looking at them graphically and both algebraically, right? So exciting. So in the last section, right, we had our little problem up here, a couple different problems that we went through and we solved like graphically and algebraically. And then 412, we're going to kind of do the same thing. Only thing we're adding on there a little bit is this thing called systems. And a system is just where you kind of have more than one equation, right, that's working at the same time. So instead of just one equation, we're having multiple equations. How exciting, huh? Right? So we have our new little problem today. So our problem is the square root of 2x plus 3 equals x. And it says to complete using, A through D. And I just didn't put A through D on the board just because it takes up so much space and then it's too small for us to be able to read, right? So I'm going to kind of read them to you. So for A, they want us to use algebra strategies in order to solve this. So when we look at our little, some days. So if we look at 2x plus 3 equals x, and we want to be able to solve this for the first part, they want us to like algebraically. So they want us to guess how many solutions do you think you're going to get? One? Two? Yeah. 1, 2, somewhere around there, right? So let's see what we kind of like come up with, right? So if we want to solve this algebraically, ultimately our end goal is, what do we want? We want to see what at the very bottom?
X equals something.
Yep, we want x equals something. So we got to work on getting this x all by itself. So when we look at it, what's the one thing that's kind of throwing us for a loop? The square root, right? So before I even start this problem, because I know that if I square a square root, it's going to get rid of my square root sign, right? So I'm going to go ahead and do that first. So the first thing I'm going to do is I'm going to square both sides. So I got the square root of 2x plus 3. Now I'm just going to throw it all in parentheses for poops and giggles. And I want to be able to square it. So if I square one side, what do I got to do to the other side? Square it. Yep. And then what happens when I square a square root?
You get rid of the square root.
You get rid of the square root, right? So on the left, we're left with 2x plus 3. And that baby's going to equal x squared, right? What do you think we got going on now?
We should probably get x on the other side.
Yeah. Is this one of those Q words? Quadratics? Looks like a quadratic to me, right? I got an x squared and I got an x. So we're going to have to solve a quadratic. So now when it comes to a quadratic, how many solutions do you think we might find? 2, right? Because we have our highest exponent is 2, so most likely we're going to get 2 answers. So to solve a quadratic, we're going to get everything on the same side. And since my x squared is positive, I'm just going to move everything over to my x squared. Right? So I got my x squared, and then I'm going to subtract 2x, and then I'm going to subtract 3. And that's going to equal 0, right? Because I moved everything over. I just kind of did 2 steps in one. Everybody good with that? Yeah? All right. So now we got to solve our little quadratic. So there's a couple different ways we can solve a quadratic, right? We can either get to where we know what our 2 factors are going to be and fill it in that way. Or the other thing we've learned is the area model, right? So if I use the area model, I know I have an x squared. I got to figure out what to do with my x's. and I have my negative 3. Right? So I'm taking these 3 terms, right? 1, 2, 3, and now I'm turning them into 4 terms, right? So I just got to figure out how to get my x's. So I know that 1 times negative 3 is negative 3. So I got to multiply to get to negative 3. So the only way I'm going to get to 3 is 1 times 3, right? And when I add those babies together, I have to get a negative 2. So we're going to go with a negative 3x and a positive x, 1x. Everybody good with those? Coming back to you. And then we're just going to pull out those like terms. Right, what do they have in common? So if I'm going this way, I can pull out an x, negative 3, an x, and a positive 1. Everybody good with those ones? Right? Right? Or if I didn't want to do the area model and I wanted to get straight to my factors, I know to get x squared, I got x and x. I'm multiplying to get a negative, and the only thing that I can multiply to get a negative is to have a positive and a negative. I'm multiplying to get to negative 3, 1 and 3, and I got to have a negative 2, so I know it's got to be a negative 3 and a positive 1. Right? Which is the same factors that we got when we did the area model. So then, zero product property says if you are multiplying things together, right, and technically these are being multiplied right there, one or the other has to equal 0. So either x plus 1 has got to equal 0, or x minus 3 has got to equal 0. So what do we get? X equals negative 1, x equals 3. And then these are our 2 solutions. Does that make sense? All right. So then now we're going to throw a little corker into the wrench. You ready for the corker? So anytime, especially in Algebra 2, because we're, the advanced students now, we're the Algebra 2 students. We're not those little guys over across the other hall taking that Algebra 1 class. So we always want to ask ourselves if our answers make sense. So far we just been like plugging and chugging, you get the answer and you move on to the next problem, you plug and chug, and then you never ask yourself, do these answers make sense? So we need to go back and look at our original problem. And I got the square root equals some number, right? So when you take the square root of a number, you're finding what times what equals that number, right? The square root of 4 is 2, right? Because 2 times 2 is 4, right? Is there another solution to the square root of 4? What about negative 2? Yeah, negative 2, right? Because negative 2 times negative 2 is going to be a positive 4, right? So we have to check our answers. And not that we have to, like where we have x equals 3, right? So I'd have a 3 here. So you'd ultimately be finding a number times a number that's going to equal 3, right? You could come up with that if you needed to. What about this guy? Negative 1. So to get to negative 1, you have to have a number times a number, and they got to be the same number, and it's got to equal negative 1. What can we square to get negative 1? Nothing, right? Because a positive 1 and a positive 1 is going to be positive. A negative 1 and a negative 1 is going to be a positive, right? So no matter what, when it comes to taking the square root of a number, it's got to be positive, right? So this guy here has got to be positive. And do we have 2 positive numbers? We don't, right? So unfortunately, we can't, oh, that doesn't work. It's like the same color. Pink. Nobody likes pink, right? So technically this x equals negative 1 doesn't work. And this guy is what we call an extraneous solution. We ended up getting that -1 because when we went through the math, we solved a quadratic, right? And in solving the quadratic, -1 is an answer. But when we go back to the original problem, that -1 doesn't make sense, right? So these guys, they make the original equation false. Make the original equation false. Oh, it doesn't even show very well. Whoop, there we go. Okay. So once we get done, we just want to look up real quick and go, does this make sense or not make sense? Just like yesterday, though, we went through and we solved these ones algebraically. But what was the other thing we did yesterday? We solved them, starts with a G, graphically, right? So I'm going to, well, we can just leave it on here. So here is our little problem that we have. So when we want to solve these graphically, we actually have two functions going on up here. Our first function is that square root of 2x plus 3. Right? And our second function is x. So you're looking at both little sides of the equal sign when it comes to graphing these. So we're going to hop on over to, what's that graphing program we like to use? So on our Desmos, we have those two equations, right? And so either side of the equal sign, we're going to put that in. So the first one we had was the square root of 2x plus 3. And then the second one was x, right? And when we're looking for equations, when they're equal, what are we looking for? Where they cross, right? So when we look at our Desmos, we're looking for where do these two functions cross? And do we find where they cross? They cross right here, right? So what variable is in our problem? X or Y? X, right? So that's the answer that we're looking for. Is we're looking for that X. We're looking for one of those where they intersect. And they intersect when the X is when the X is 3, right? And when we did it algebraically, did we get the same answer? Yeah, we did, right? Because we ended up getting the -1 and the 3, and we knew the -1 couldn't work. And when we look at our square root here, right, that's our green graph. When it comes to our square roots, right, we know that we don't have negative square roots. Because negative square roots are what kind of numbers? Starts with an I. Imaginary, yep, exactly. Pardon me? I didn't hear you.
Why can't you just like put the equation in at the beginning and get through? Like, you just insert it in the Desmos and you're
right.
Why can't you do that?
Because sometimes in life you don't have decimals in your back pocket. And then the crazy part even on this, if you want another way that we can solve this, remember when we went through, yes?
Could you like solve all of them just by putting them in like decimals?
Yes.
Or is it only like certain ones?
Nope. I mean, if as long as they intersect, then you can put it into decimals. Yep. So lo and behold, you'll probably have some non-graphing calculator usage on quizzes and tests, right? So that way we know you know how to do it. You know what I mean? But yes. Yep. And then the crazy part about this is, remember when we took our problem originally and we went through and we got to this little quadratic, right? You could actually put the quadratic in what do we have? We had, nope, x squared minus 2x minus 3, right? And then when it comes to quadratics and you're solving those quadratics, you always look for where they cross the x-axis, right? Because you took both of those equations, or those functions, and you made it into one. So there's where your x equals 3. But then we knew that we couldn't use the negative one, because in the original problem, it makes it false, right? So there's always more than one way to skin a cat. Isn't that crazy? All right. Let's try another one. All right. And this is part of it. Like, they want you to kind of look at these, look at them algebraically, look at them graphically, and making those connections. So this problem looks really crazy up here, doesn't it?
Well, can't you like just put some of it together, squeeze it together? But
Squeeze it together. All right, make some orange juice. Squeeze, squeeze. Right. So which way do you guys want to go first? Do we want to go algebraically or graphically? You tell me. A or G?
algebra.
Want to do it algebraically?
Well, just to know how to do it.
Right, yeah. So we'll start off with algebra. We like algebra, right? So I'm just going to rewrite the problem. What do we got? 2x squared plus 5x minus 3 equals x squared plus 4x plus 3. So let's, can you see the pink? Is that all right? Yeah, we'll switch it around. So ask yourself the question, how many solutions do you think you might find?
4.
4? Anybody else got anything?
Because you were going to use the x one.
2?
Maybe just 2.
Maybe just 2?
On each side, so.
Right. Yeah, we'll see, yeah. But you're at least getting a mindset, right? Maybe 2, maybe 4, right? So always ask yourself that one, because then when you get done with the problem, then maybe you can go, oh, we should have had this many solutions, and then in the future, right? All right. So if we want to solve this quadratic algebraically, what do you think we need to do? What do we do with all quadratics? What do we like to do? Get them all on the same side.
Add 3 and then subtract 1.
Right.
And then subtract 3.
Yeah, so what I do when I look at these, I always look at my x squared. For whatever reason, I like my x squared to be positive and not have to change it later on in the problem. So that's usually always my go-to. So it's like, do I want to subtract the 2x from both sides, or do I just want to subtract the x squared from both sides? And for me, like, I would choose to subtract the x squared from both sides because it keeps my x squared positive. And that's what I need in order to factor it, right? If I want to use the quadratic formula, it doesn't matter. But if I want to try and factor it, I need to keep my x squared positive. So, you want me to go step by step, or do you think we can do it all together? All right, we'll try and do it all together, right? Oop. So we're going to subtract the x squared. So that's going to give us the x squared, right? Subtract the 4x, so plus x. And then subtract 3 minus 6, and that's going to equal 0. Did you guys come down with the same thing? Because you guys are trying to do these on your own, right? Not just copying whatever, right? Yep. How many solutions do you think you might get now?
1 or 2.
Right, yep. So now we got to factor this guy. So we can either go straight into our factors, or you can use the area model. So what do we got? X and X. A times C is going to give us a negative number. So since it's negative, we know we got to have a positive and a negative. I got to multiply to get to 6. So that's either going to be what? 1 times 6, 2 times 3. I got to get the difference of 1. So I know I'm going to use my 2 and my 3. And it's positive. So I know I have a positive 3 and a negative 2. Right? Set these guys equal to 0. X equals negative 3. X equals 2. We got two solutions. Right. When we look back at our original problem, do you think there's any restrictions on that when it comes to these two guys? You think we could use both of those in the original problem? Yeah, right? You can square a number, right? It's really just those square roots that are the ones, or if there's an x in a denominator, right? Those asymptotes, those are the types of things that are going to really get us. So that would be solving it geometrically. What would we do to solve it graphically? What do we need to do? We're going to put each of these in separately. Right? So that's my first function. And that's my second function. And then what am I going to look for? Where they intersect, right? So we're going to slip back over here to Desmos, right? And then, so what do we got? 2x squared plus 5x minus 3. And we can make sure we put it in right. Should it be a quadratic? Yes. Should it be opening up? Yes. And then our second one was x squared plus 4x plus 3. And we're looking for where they intersect. So did it intersect right there? -3? Did we have a -3? Yeah, we're getting there somewhere. Then we gotta follow these two up here somewhere. Oh, 2? Did we get 2? Yeah, right. Sound good? Right. Let me see, I think that was. Yep, so A was how many solutions do you predict? We predicted either 2 or 4, right? We ended up getting 2 answers. So if we go back to that original problem, right? So our clue, oops. Like remember how we had the quadratic on both sides to where maybe there were 4 answers, but we ultimately know we had to combine all of those together. So once we combined them together, right, you have that x squared, so it's going to be 2 answers. We solved it algebraically. Right? Then we went through and we solved it geometrically or graphically. And then when we solved those graphically, we looked for where they were intersecting. Right? Or even graphically, you could have just put this quadratic in. Right? If you just put the quadratic after you got everything on the same side. And when we got it all on the same side, we ended up with x squared plus x minus 6 equals 0. So you're looking for where it equals 0. So at -3 and at 2. Life is about options, right? You guys want to try a couple of these on your own? Right. What would happen if we graphed 2 functions and they never intersected? What would happen then? What would that be? No solution, exactly, right? So you might get it where you graph 2 different things and just where they graph, they don't ever intersect. So then there would be no solution, right? Like if we had, let's say, x minus 7, right? There's an example. So this would be like an example of no solution, right? Because they never intersect.